Hello, everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 2A. My name is Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the ninth World Conference on Smart Trends in System Security and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom today and tomorrow, that is 20th and 21st of August 2025. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have six presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I will be raising a gentle reminder. There is another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any query or update, then you can write it to me in the chat box. So just before we start the session, I'd like to introduce you all to the chairs for this session. Firstly, we have Dr. Dalia Ahmed Monti Hassan. Dr. Dalia is the Vice Dean of the School of Computer Science at CIC Canadian International College, Egypt, and an Associate Professor of Management Information System. Formerly head of the Information Systems Department at the French University in Egypt. She also serves as co-director of the CRI Research Lab, contributing extensively to research and academic leadership in information systems. Welcome to the session, ma'am. And then we
Hello,
have
good
Dr.
morning.
Deepika. Yes, ma'am, would you like to give an opening remarks to all the participants?
Hello, good morning.
Good morning, ma'am. Welcome to the session.
Thank you. Thank
Okay, so next up we have Dr. Deepika Virari as a session chair. Dr. Deepika is an assistant professor in Information Technology Department at Army University of Technology, Pune. She has total 8 years of teaching experience. Dr. Deepika has published 20 plus research papers in various Scopus, indexed, and UGC approved journals and conferences. Currently, she is associated with research work in different domains like image processing, machine learning, data mining, and artificial intelligence. Welcome to the session, ma'am.
you. Thank you, ma'am.
So, moving forward with the papers now, our first presenter is Moses Swapanta with the paper title An Approach to Artificial Intelligence Tools and the Legal Basis for Cybersecurity Governance. Sir Moses, if you're here, you can start presenting your screen.
Good morning.
Good morning.
Moment, please. Share screen.
Yeah, you can share your screen now.
My name is Moisés Papanta of University Técnica Ambato, Ecuador. My presentation on a project to artificial intelligence tools on the legal basis for security governance. Contains introduction, problem project, overall, material and methods, result, future work conclusion. Introduction, persistent cybersecurity governance change on the global concern, particularly evident in Latin America and the Caribbean, while Ecuador servicing case study. The contribution factor including the lack of the adequate the legal framework for artificial intelligence, AI, tools in the insufficient application cover 2015 methodology. The problem a project, cybersecurity governance problem persisting in public and private organization worldwide in the covering and the case study Ecuador on the May causing the rise of the life for the use of artificial intelligence in Ecuador. Unlike adequate artificial intelligence tools and the parts in the information methodology manager in the governance in the level according with the COVID 2015. A recommendation when defining ECT as the OMS, the World Governs Organization, among others. Overall, the objective in the general artificial model and the legal basis for security governance. Materials. The materials used in research are insufficient article office website lines and the regulators in conduct respectively analyzing the current status of legally project based artificial intelligence for cybersecurity governance. Methods. To conduct the research, the deductive exploring methods and the work also the review issued articles official wise regulation and the other sources for information analysis. The methodology applied in the obtained result was carried of in first phase. First phase. In the first phase, the problem of the cybersecurity governance situation were review and analysis from different perspectives according to the authors on the review document. The global was the generated indicators in the world allow determinants in the stage cybersecurity governance. Second phase, the information from the reference 1 to 10 was analyzing the identification the status cybersecurity governance. According in Ecuador, we have 51.3% ranking the global cybersecurity index 2025 Future in the determinal that Ecuador have a score of 0.0 to 20 in the organization Missouri pillar. First phase in the formation from article 1 to 23 in the analysis to identification the indicators in the survey in the power in the cybersecurity governance in an organization quite similar in technology infrastructure characteristics. For phase, other analyzing the previous phase in defining an artificial intelligence to model in the legal phase in the cybersecurity governing relevant stakeholder that can implement the future to mitigate risk, vulnerability, and trends in cybersecurity governance manager. Result one indicators in the identification status cybersecurity governance indicator legal technology articulates right in the cybersecurity governance one reference one proposed indicator a regulatory maturing index cybersecurity 2 IE security maturity index the cybersecurity 3 advancing the raise in the efficiency in the IE based cybersecurity solution 4 integrate maturity in the flow security governance 5 implementing maturing IE probably security governance 6 cybersecurity governance maturity IE adoption 7 indicator in the legal ethical adapter security governance 2IA A system and integration indicator I risk orient security 9 ethical regulatory information indicator for security and governance 10 artificial intelligence model in the legal basis of cybersecurity governance, fundamental principle, security by design, privacy by design, transparency and scalability, robustness and resilience, accurately formatting the to contain information, cybersecurity governance model, political strategic layer, risk and compliance layer, open operation and technology layer, response and enhance layer, incident layer. Legal Basic Operation Cybersecurity Governance, WIA, existing legal frameworks and application, and leg frameworks speak to AI, key consideration for legal governance, consideration interest. Discussion. In the material fast articles for web analysis from reference 2011, 11, 23, all present in general purpose cybersecurity governance with the integration of official intelligence. All contribution in the result de generator or indicator in the identification status cybersecurity governance indicators to measuring the impact cybersecurity governance and artificial intelligence and the legal basis for cybersecurity governance. Future world. Research on the cybersecurity governance must continue and the next publication on the present the result in the indicators on the determination on the model for implementation. Conclusion is was concluding the appropriate artificial intelligence model and legal basic adjunct for mitigation risk, vulnerability, and trends shown that cybersecurity governance managed in the confidential why integrity and availability. Thank you. Any question?
Am I audible? Yes, am I audible?
Yes, you are audible.
Sí.
Okay. Uh,
Second
Question is,
presentation.
what measures should be placed here to ensure the transparency as well as the accountability of whatever the AI tools you are using in this cybersecurity concept?
A security information global security problem in Ecuador in base legal problem in security. I know no disposing the reglement in intelligence artificial.
Okay, thank you.
Moment please, presentation, segundo paper, second paper. Moment please.
Yeah, thank you for the presentation.
Sí.
Moving on to the next, we have Sir Moses again with the paper title Analysis of the Legal Framework for the Cybersecurity Situation in the Ecuadorian Government Sector. Sir, you may
Moment
please
please,
go ahead.
second presentation, second paper. Second presentation paper and topic analysis on the legal framework in the security situation, Ecuador governance sector paper. Contenidos, introduction, problem, a project, overall, materials and methods, result, future work, conclusion. Introduction is cybersecurity translation aspect in society implementers, trends, encryption, authentication, and asset control measures to project data and network from unique introduction in malicious activities. While is this, there is in common such cybersecurity personnel that it also ensure the operation continuity intention in its development in the ever-ongoing digital transformation. Following appropriate, the core is the fragmentary insufficient and also natural or the occurre legislation. Why the exhibition regularity has inconsistent among case law in the simplificar this come from international standard, thereby limiting the effective protection in public institutions. Our goal this in the objective of the analysis Ecuador in the framework in this scope in the efficiency against digital race impact in the public sector to identification critical areas recreative reform. Material initial in the material section various legal framework relational to cybersecurity in Ecuador were reviewed along with academic artists and specialty study addressing the risks and the change in the digital arena in public sector. Security in the methods and section tools from the market legal analysis in the comparative method were applied to identify the scope where is contradiction in the regulatory representation in the current legal framework. Methods the deductive method and exploratory research were used to say analysis information from different official ways, like regulatory and insufficient articles in different specific database. To arrive the result, the project's relevant information was consideration a part in the process in the analysis the information. Information technology and the fundamental the factor in essential social activity, such education and project, commerce and the healthy during 2020 in the Ecuador associating the telecommunication companies and the associated internet providing company among 40% 30% increment in the demand in internet service. Likewise, in the Ministry, the Telecommunication and Information Society report a 14% increment in network traffic. This was a direct cause the popular in the direct result for technology containing the order application direction international congregates 2021 Ecuador managing the surprise 11.5 million internet subscription, the 11 rose in the difficulty and change in the cybersecurity positive in the country 60 fast in the Latin America in the most malware detection and 75% incremento in cyber incident. Result one digital growth indicator as cybersecurity percent internet demand network traffic internet score factory incremented cyber incident malware detection ranking. A model for framework cybersecurity in Ecuador, the Constitution of Ecuador, protection against risk, privacy, national cybersecurity policy, 2022, relative 70, article 3 and fictici, database technology, integral o orgánica penal código, computer crime, special units, cybersport, attribution con OEA, ONU, OTAN in the governance of the business increment. Discussion, this document presentation criminal assessment in the Ecuador regulating framework, the governance, cybersecurity, relevance, structural and operation in the company state digital protection. The result of this research arrived with the reference in the foraging aspect in deficient legal framework in the face cyber crimes in the net in the profound legislative reform the emerging crime the importance in the alliance international standard and progress the Lopez is regulative base. Future War, Future War shall focus in comprehensive legislative proposal on cybersecurity for Ecuador, taking into account the fronts finding the study and the ones already there welcomes international fronts, responsible citizens in the digital space address national insecurity. Conclusion is what included in the Ecuador cybersecurity legalized light concurrence and the other resulting in the regulatory has in the response to resolutive response criminal incident in the world regulatory incompatibly because in the copy criminal code in Spanish the laws data protection are Spanish and a current legislation. Thank you. Any question?
And we have Sir Fernando with the paper title Characterization of Artificial Intelligence AI and the
Yes.
Cognitive Process.
Okay. Thank you very much. This pleasure to present this article, which is very important and the relevance to academic and the scientific community and beyond. I sincerely apologize for not being fluent in English. I will try my best. I'm Fernando Kisanga, Director of Science Research and Postgraduate Study at José Eduardo dos Santos University in Angola. And my co-author is Vice-Rector Professor Dr. Ataúfo Pereira. We would like to thank this conference organizations, committee, and their support. Thank you very much. I believe we are the first Angolans to participate in this conference. We are very proud. We would like our flag to also to be placed on your website. I see, as I see other countries. However, I shall begin my presentation. In introduction, artificial intelligence has become the technology epicenter. Every scientific, academic, and technology approach prioritize artificial intelligence here, which has been characterized as the modern technology in the future. As it encompasses the various fields, including medicine, and food industry, film, aerospace, the military, transportation, education, architecture, and telecommunication, IT, robots, automation, culture, art, and design. We believe there is more ovation. It will know that intelligence is only not able to humans. So we learn from various scientific advancing every day. math. Sorry. This research is a qualitative, using a quantitative techniques based on a bibliography reference that were colored from books, journals, scientific research manuals, and scientific article. A study was conducted based on survey and interviews of the essential their role in learning. It was necessary to frame documentary research, which allows the authors to express knowledge on the topics of teaching and learning. Information and communication technology, multiple intelligence, and artificial intelligence. Artificial intelligence, also known as AI, is a branch of science to aims to simulate human intelligence found technology means. It can also be used platform research of scientific research, collaborate work, and the business opportunity such as creation and incubators, and purpose for strategic business manager projects using AI. Example, including ChatGPT, Visual Mind, dashboard, business intelligence, and CRM, and project management. Learning factor and the cognitive process. The cognitive development reference each individual's mental ability over or given a period of time, involving processes such as participation, attention, and memory, reason, and the appropriate language to resolve adverse situations. Result and discussion. In a study, um, carried to by scientific at MIT, Massachusetts Institute of Technology, who prepared a survey for 55 participants. It was noticed that there remain big cognitive loss for those who use ChatGPT. However, this makes us lazy. We understand that is an important tool without taking away its merit, but we just need education for better application. Along these lines, we cannot, the ChatGPT doesn't allow children and adults to use all part of our brains. In this case, cognitive exercise isn't performed by the brain. For example, the cortex frontal and the prefrontal regions, and these are brain regions where less activity. Indicate that there was no activity brains. An electrocephalogram is used to record brain activity, such as to record the brain's electric activity, or to detect brain problems or diseases. This tool was crucial to research outcome. In here, tools, specific ChatGPT facilitate the writing on the testing. We not exercise neurons tend to be less intelligent. If Fassi say that reason capacity decreases and the cognitive process, decision making. So, the imperative is of simile in neural circuit. Our neurons are what allow us to perform fiction and activity. they commonly found or synapse. If a region is not simulated, they may be cognitive loss. So in these words, we need to exercise them brain areas because they emit synapse. Conclusion. To understand this topic, however, ChatGPT is an innovative tool that brings paradigm shift. However, its use must be cautious as it not a therapist or doctor or substitute for any human being. Over day and over the 100 billion neurons, each one is more intelligent than yeah. In other words, those tools were created on a neural base, which is why the study of neurosciences is fundamental. However, otherwise, the study showed that they may be cognitive loss using ChatGPT. They make us very lazy. It is that is we stop engage in critical think and exercise the knowledge. However, we we agree that ChatGPT can weaken cognition. Thank you very much for this time. Thank you very much. I don't know if you have one question.
Yes, I have one question. What the limitations you found while applying the current AI? Consider this complex cognitive task emotional intelligence or creativity. So, do you found any limitations related to the current AI?
Um,
Yeah, I'm audible.
sorry.
Am I audible?
I can hear very well.
Anisha, ma'am, am I audible properly?
Yes, you're audible.
Yes.
Okay. My question is what limitations you found
Well, I
applying the
think
current AI?
yeah, I think this topic is very important in our countries and no, so our country in the world because the chat GPT sometimes is all things that make a difference our study. But now we know that the chat GPT sometimes we make when you use it always chat GPT, we make sometimes we can be lazy because the whole thing you seek you don't use it all party of brain. So that is very important to make a difference. ChatGPT is very important, but you can use counter. You can use no, because the children, like the topic that I told, the children neuroplasticity is very important to difference, to make a difference. The chat GPT and use it like a study of the Massachusetts Institute say that the brain, when you not use your brain, so you lose cognitive process. I think that is very important to talk about this topic, the ChatGPT and the cognitive process.
Okay, fine. Thank you.
Thank you for the presentation.
Thank you.
Now we'll be moving forward to the next presentation. And we have Kavi's Bhumi with the paper title ChatGPT assisted review of IoT for agricultural disaster early warning. Do we have Kavis here with us in the meeting?
Yes. Do you hear me?
Okay.
Okay.
Yes, you're
Wait a
audible.
moment
You
for
can start your
sharing.
presentation.
Yep, thank you. Do you see my screen? So, excuse me, do you see my screen?
Yes, it is visible.
Yeah. Okay. Uh, Good morning, everyone from the London, and good afternoon from the Thailand. It is honor to have the opportunity to present to you today. My name is Chwip Bunmi. I'm from Department of Industrial Engineering, Faculty of Engineering, Chiang Mai University in the Thailand. The topic that would like to represent to you today is it also is related to the research in the ChatGPT as well. We use this ChatGPT to help us to make the literature reviews in the IoT for the agricultural disaster early warning system. Okay. For the first, I would like to tell you that I'm not the expert in the IoT or the advanced or the AI, something look like this one. I just the beginner and would like to apply all of this one in the agricultural disaster early warning system. For this, my presentation, I would like to separate the presentation into 5 main parts. That the first, I would like to talk about the introduction and the inspiration of my research. And next, I would like to represent you about the methodologies. And then we would like to talk about the results and also the synthesis toward the framework that I would like to propose. And then finally, I would like to talk about the conclusion of my research. Okay, let's begin in the first main part about introduction. Okay, based on I from the Thailand. This is the map in the Thailand. And my home country, my hometown is the northern of the Thailand. That located in here, we call it Chiang Mai province. And the Chiang Mai province is around by the mountain and the rich in the beautiful natures. Most the people in the northern Thailand are the farmer. We usually to grow the crop, for the example of the coffee, tea, and many other local products as well. However, in the Chiang Mai, we also have been to face with the many disasters, including to the flood and including to landslide as well. In which this one, this problem are getting the worst because of the deforestation and also the change in the land is used. When the disaster occur, it means that it also can make the effect to the many people, effect to the farmer, effect to the animals, effect to the crop, and also effect to the economy as well. In the Thailand, we usually to read the disasters after they happened. But in the highland, the landslide happen often, but there is no early warning system to help the farmer in that area. So it means that they have to face with the big loss and also have to wait for the long time to help us. So based on this one, I would like to find something that help the people or help the farmer in this area to warning about the disaster or the landslide in this one. So my research question is, what are the current trends and the technologies and the challenge in implementing the IoT-based early warning system for agricultural disaster, especially in the highland farming region as well. Based on this one, we also propose the methodologies of this research that I can separate into 6 steps. For the first step, we start from to find the word or find the word and to search in the database, in which the database that we would like to make the literature review is based on the Scorpus database. The wording that we use for searching in this one is consists of the Internet of Things, early warnings, disaster warning, flood detection, landfill detection, agriculture, farming, and also the rural community as well. After we search the word all of this one already, we will make this a screen in the step number 2 that this one is is under our criteria or not, in which we are considering the criteria in the paper only. There's the English paper only, and also it have to publish between 2000s uh, 13 and to the 2024 only. And after we make the screen again by look at in the title and also the abstract as well, that this paper is related to our scope or not. If it's not, we will be cut it. Okay, and after we got the complete list, the paper that relate to our studies already, we will use all of this one to make the classification, in which this one, the classification, we will use the large language model for make the classification in this one, in which we use the advantage of the ChatGPT to LH to make the classification in the following the topic that we would like to know. This show about the prompt that we use the ChatGPT to make the classification, including to the country of the study, IoT components, application area, alert method, disaster type, and also the type of the agriculture as well. Based on this one, after we got the classification already, we go to the next step to do the data synthesis, in which this step we try to learn and try to understand the result that we got from the ChatGPT as well. After we know about this one already and we also have some knowledge already, I would like to propose the IoT frameworks for the agricultural disaster prevention. Okay, for following the step that I'm proposed to use already, the result that show in this slides. For the first, we have to separate and find the significant paper that we input in the ChatGPT, right? So we start from to collect the data from the Scorpa database that we can collect around 104 papers. After that, we also make the screen as well, because of some paper might have the duplication publication as well. But based on in this one is the number of the paper is still equal to the 104 as well, in which it means that it don't have the paper that have the duplication papers. And after that, we also make the pre-screen again based on the inclusion and also the exclusion criteria. Based on this one, from the papers 104, it will remain that only the 82 paper, because of some paper is write by didn't use the English. It is another language, including to the China's and also another language as well. And moreover, in our scope, we will focus only on this the international journal papers, conference papers, and also the books only. So if it's not in this scope, we will cut it. So it means that it will remain that only the 82 papers. And after that one, we also make sure that all of the papers in 82 paper is related to our scope. So we study to learn and try to read about the abstract. If it's in our scope, it's also we continue and can be used to make the analysis by using the ChatGPT. So the finally study, we also remain the paper around the 49 paper as well. Based on this one, after we input all of the data into the ChatGPT, that we got the data from the Scopus database already, we can make the classification following like this one. And it also can show some significant that we also can get the knowledge, also know about the existing research from the ChatGPT as well. Based on the classification, the result that we can know about this one. The first, if we look at in the IoT or the technology that they usually to apply in the agricultural, of course, the sensor is gonna be the number one that they have to use. For the sensor, this one, the sensor is quite useful to collect the data including to the temperature, humidity, soil moisture, and also the rainfall and the water level as well. Because often, if we would like to make some prediction, some things, the criteria of this one is should to be input in the in the models. And moreover, we also can find that most of the paper recommend us to make the integration between the microcontroller and also the GSM and also there's a LoRa communication because of they represent that when you would like to make something in the urban in the rural city, it might don't have the internet. So maybe we also can use the wireless, also can use the GSM, also can use the LoRa instead of to use the internet connection. If we talk about the alert system in this one, many people also recommend us to use the multi-platform alert as well, including to the buzzer, including to the light, including to the sound, and some paper that also has been to apply the alert into the in the mobile applications or the light application already. And for the disaster that most of the people usually to focus, they usually to focus in the flood only. But that the field paper, they will focus on the landslide and try to apply the IoT in the landslides. And moreover, we also can know that most of the IoT solutions target general in the crop farming only, without only fields focus on the rice or the greenhouse. And finally, many papers also recommend that several papers usually to adapt the AI with the cloud technology to help us to predict about the risk area, about the risk that the disaster is might occur in the future as well. Based on the knowledge that we got from this one already, I also can propose the framework that I would like to make the to design in the futures. Based on this one, you will see is that I have like the four in the connection layer in this one that we will use. For the first, of course, we need the sensor first. The sensor is quite very important because it can collect the data from this one, including to the soil, including to the rainfall and water level, and also the slope instability as well. Okay, and the data is processed through the microcontroller, and we also would like to apply the AI in this one in order to predict the risk level in this as well. For the data, it will transmit via the LoRa or we can use the GSM network, which are well suited for remote the highland area with the limited internet connection. In this one, that's sure. And after we can make the prediction already and can separate the list level already. After we know about the list already, it will send to the people or the farmer in the effect zone. After we know about this one, it's not only we can send the message, but we also can use another alert channel, including to the notification line or the loudspeaker or the dashboard or the light or the buzzer as well to inform to the farmers. When the farmer knows about this one already, they also can make the plan. If it have a high risk, the farmer is will evacuate or not. They have to make the protection for their crop or not, or they have to evacuate their animal or not. Something look like this one. And not only about the planning for evacuate only, but we also can use all of this the prediction level on this one to make the recovery planning as well. Because of if we can implement the soil or can implement the land is in the future the landslide is might be have like the low list as well. Based on this one, we in this research we also can make the conclusion that based on the systematic review of the 49 study we can also identify the core component IoT based early warning system by using the large language model for the highland agricultural disaster management as well. And we also can propose the frameworks integrating between the real-time sensings, HAI, multi-channels alert, and also the post-disaster recovery to tailors to the upland farming in the Chiang Mai as well. This is the end of my presentation. Thank you very much.
Yeah, can you please tell me that how can the small scale farmers will be using this development and the deployment of this IoT warning system?
Again, please, I cannot hear clearly.
Yeah, how can the small scale farmers can be use this system better way?
I don't understand your question. Can you explain it again?
Am I audible properly?
What?
Am I audible?
Yes, ma'am, you are
Yeah, I
audible.
can hear you.
Yeah, my question is how can that small scale farmers will be using this development and deployment of your IoT warning system in better way?
Based on my knowledge, I tell you that I'm not the expert in this one. But for more smart in this one, it's also based on um, the purpose this one. We also can make it more smart by using the AI. And if it's not smart yet, maybe we have to get the feedback from the user and then try to develop it again. Try to make like the loop and try to implement it continually.
Okay, that's it from my side.
Thank you very much.
Thank you so much for the presentation. We have Vani Hiramani with the paper title High Fidelity Audio Watermarking, an end-to-end deep learning approach for an uh, imperceptible and robust embedding. Do we have one here? Yes. Okay. You may start with your presentation.
Yes, ma'am. We along with Vani ma'am and our co-authors are here.
Okay.
Just a second, we'll get started with our solution. So, good morning and namaste to everyone from India. Today, my team and I are going to present a project titled High Fidelity Audio Watermarking and End-to-End Deep Learning Approach for an Imperceptible and Robust Embedding. This project has been carried out by me, Divyansh Kumar, along with my teammates Atharva Gundali, Trisha Boda, and Spandan Chauhan, under the guidance of Dr. Vani Hiramani and Dr. Shashikala Mishra. We are from Symbiosis Institute of Technology, Pune, and this project aims to tackle the growing challenge of securing audio content in the age of generative AI. So this is the roadmap of our presentation. We'll begin with the problem statement and why we think audio watermarking is important. Then we move on to the data set we've used, followed by the model selection and pre-processing techniques. After that, we'll explain our model architecture, system design, and finally we present the results, conclusion, and future work. So we'll get started with our problem statement first. So as you can see, over in a survey conducted by McAfee, over 83% of Indians have lost a monetary something of monetary value because of audio generative voice calls. Personally, we have faced this problem in our second year of engineering, where Spandan's parent got a fake call from an impersonate claiming to be a police officer. And when his parents were asking to talk with Spandan, they were presented with a fake audio clip of his voice, which was convincing enough to his parents. This situation was especially stressful for Spandan since they were unable to verify at that time because Spandan's classes were going on. This led us to wonder if even if our parents being digitally literate were still susceptible to such an attack, what would be the scenario for the rest of the world? So this led us to filter. Uh, this led us to survey work that has been done in this field, which mainly guided us to. There were uh, two main approaches to this. One being physical. One being physical watermark based, and the other ones were deep learning based. The physical one relies on mathematical equation like Fourier transform, least significant bit, or quantum index modulation. But these methods are susceptible to adversarial attacks such as playing the voice in different speeds or changing the frequency. From this survey, we concluded that deep learning methods are more suitable for modern audio watermarking, as they can balance imperceptibility with robustness against compression, noise, and resampling attacks. In our literature survey, we found a lot of deep learning frameworks such as Cipher, AudioStamp, and DEAR, which have improved perceivability and resilience by leveraging cycle across acoustic models, wavelet transform, and different compression. So moving on to the data set.
During our literature review, we came across the Vox Populi dataset and LibriSpeech ASR corpus, which we have used in our model training and validation. We have primarily worked with three datasets: Vox Populi, LibriSpeech ASR corpus, and a custom song dataset. We have selected these three datasets because one, they are open source and publicly available. Two, diversity of speech. These datasets cover a wide range of accents, pronunciations, speaking styles, and narrators, which would ensure that our model would be generalized. Three, it has sufficient hours of audio to train our model and also maintain computational efficiency. Vox Populi. We have used the Vox Populi dataset, which is a large multilingual speech corpus released by Facebook AI. The dataset has about 400,000 hours of speech across 23 languages. For our work, we have selected the English subset, which is around 5,400 hours. And this dataset is highly diverse, covering a wide range of accents, speaking style, and pronunciations, which make it ideal for training models. From this dataset, we used about 200 hours of audio, carefully chosen between balancing training needs and computational efficiency. LibriSpeech. Our second dataset is LibriSpeech, which contains around 1,000 hours of 16 kilohertz English read speech derived from the LibriVox audiobooks. It provides well-segmented and aligned audio with different narrators and accents, which makes it suitable for evaluating ASR systems. We have worked with around 5,000 audio files specifically for validation. In addition to the spoken datasets, we have also created a custom songs dataset by randomly selecting audio from YouTube, and this gave us exposure to varied accents and music genres. We prepared about 27,440 audio files from this collection, which we have used for the validation.
Now I'll explain our model selection process which guided us to our final architecture. So we evaluated CNNs, RNNs, and transformer models across our key requirements, which were temporal signal processing, sequential dependencies, detection tasks, and our constraints, which was the watermark should be imperceptible while the system as a whole should be efficient. Based on an analysis, we selected CNNs with rest blocks for temporal signal processing and detection due to the effectiveness in audio classification. For the sequential dependencies, we chose LSTM components for the efficient temporal modeling, while to balance all the constraints, we adopted a hybrid CNN LSTM approach, which combines the CNN's spatial feature extraction capabilities with the LSTM's temporal modeling. This systematic evaluation ensured our architecture choices aligned with our specific requirements and constraints.
Shown here are the pre-processing steps that we have performed. We started with the Vox Populi English data subset, which has around 5,400 hours of raw speech data. This dataset is extremely large and contains a lot of variability. So the first step was extraction. From the full dataset, we extracted about 200 hours of representative audio to strike a balance between diversity and computational efficiency. Then we segmented the extracted audio into 1 second clips. 1 second is considered the smallest and most effective duration for speech processing, and it is also long enough to capture the phonemes, syllables, or short variables, short words, and ensures consistency across the dataset. Using uniform 1 second clips also makes it easier for neural networks to process and increases the number of training examples, which leads to better generalization. After segmentation, we have performed speech versus noise classification. Human speech generally ranges between 300 and 3000 Hz. So we applied a band energy filter to separate speech from background noise. This step reduced the dataset to about 100 hours of clean speech, which ensures that the model learns from actual spoken content than silence or irrelevant sounds. Once we had speech-only clips, we applied normalization to convert the multi-channel recordings into mono, and this was necessary because recordings have different loudness levels. Normalization ensures consistent dynamic range across all the clips. We then resampled the audio to 16 kilohertz, which is a standard sampling rate for speech recognition. It is high enough to capture the important speech frequencies, and it is efficient in terms of processing. Finally, all the processed 1 second audio clips were stored in a separate directory with updated metadata that includes file paths and durations. This organized format makes the dataset clean, structured, and ready for training.
Now I'll walk you through our system architecture from left to right following the complete data flow. First, we begin with the raw audio clips, which are our initial inputs. Then the audio clips undergo several pre-processing steps, which were explained earlier, and then they are finally split into training, validation, and test sets with an 80 is to 10 is to 10 ratio. Then this processed audio clips are fed into a generator model. This neural network utilizes an encoder, LSTM, and decoder architecture, which outputs the delta, which is actually the watermark signal. We then add this outputted delta to the original audio, which creates the watermarked version. Now both the original audio clip and the watermarked version are fed into a detector, which is a CNN with res blocks, and this detector produces the detection probabilities. Next, our loss system computes our multi-objective loss, which consists of 5 primary losses, which help improve the watermark generation and detection capabilities. The 4 main losses used are L1 loss, a MEL spectrogram loss, time frequency loudness loss, and detection loss. Finally, we evaluate our system using confusion matrices and compute metrics such as SI-SNR for quality and the watermark RMS magnitude. Finally, the system produces both the performance metrics as well as the watermarked audio files for further analysis. These are our detailed model architecture diagrams.
Coming to the results, as we can see from our table, our model is highly effective. On the Vox Populi and Libre speech dataset, which have over 40,000 samples, we achieved a near perfect accuracy of over 99%. Even with our custom songs dataset, accuracy remained very strong at 96%, demonstrating the model's excellent generalization. Our watermarks are virtually imperceptible, which achieve a high SISNR of around 21 decibels for both speech and music, which is well above the threshold of human hearing. Additionally, our watermark's impact on audio quality is minimal, with a very low watermark RMS value of only 0.007. Finally, our F1 scores were considered high, confirming the robustness of our detection. To visualize these results, let's look at the graphs. The bar chart on the left clearly shows our high accuracy across all datasets, which is Vox Populi, Libre Speech, and custom songs. The confusion matrix on the right further confirms our model's reliability with high numbers on the diagonals, indicating accurate detection of both cleaned and watermarked audio. Below that, the waveform plot visually proves the imperceptibility of a watermark. As you can see, the original and watermark waveform are nearly identical, showcasing how seamlessly the watermark is embedded. Comparison. Traditional audio watermarking struggles to balance accuracy, imperceptibility, and robustness. The detection accuracy is often lower, especially with noise or compression, and the imperceptibility is often poor with an SISNR below 18 decibels. They also have limited generalization, often failing to work across different audio types. Our deep learning model provides a significant advancement. We achieve over 99% detection accuracy for speech and 96% for songs, and our watermark is highly imperceptible with an SISNR of around 21 decibels. Most importantly, our model is highly robust to compression and noise, and it will generalize across both speech and music without needing to be retrained. This versatility is a key differentiator. Next. To conclude, in today's digital world, protecting audio content is more critical than ever. Traditionally, watermarking methods can keep up with modern threats. Our deep learning system directly addresses these challenges by embedding imperceptible yet resilient watermarks. By leveraging advanced neural network and adversarial training, our approach is highly resistant to noise and other signal distortions while preserving audio quality. This project delivers a secure, efficient framework that empowers content creators, enhances digital trust, and ultimately safeguards media integrity. This system represents a significant step forward in protecting audio content in our increasingly digital world.
Now I'll quickly go over the future work which we have researched. So we have identified 5 key areas for extending the research. The first and the most important one would be to train on a larger, more varied data set, which would help increase the system's robustness. The next would be to develop a pipeline which with a sub 100 millisecond latency would be useful for live applications such as broadcast watermarking. Next area of research would be optimize the models for mobile and edge development, therefore enabling on-device processing without cloud connectivity. Then security integration, where we'll add cryptographic key supports, further improving our security. And finally would be to create lightweight uh, software developer kits in Python and Node so that our system can be easily integrated into a varied amount of softwares. This extensions would help transform a research prototype into a production-ready commercial system. Thank you.
Hello.
Yes, ma'am.
Yes.
Yeah, just a small question. Is there any legal or ethical consideration you have taken regarding the use of audio watermarking? Is there any need?
Uh, Actually, this will be a completely optional system wherein if the user wants to watermark, then only they can. And it doesn't disrupt the original audio file in any way.
Okay, fine. Thank you. That's it from my side.
Thank you so much for the presentation
Thank
to
you,
all
ma'am.
the authors. Now I'll be moving forward to our next presenter. Yes, and the paper title is Deep Learning and IoT Fusion for Wildlife Detection in Agriculture, a case study on bird activity and agriculture fields. Yes, you may please start now.
Okay, thank you. IoT Fusion for a case study on bird activities in agricultural fields. So, what are the things we are going to be covering or we are going to discuss this introduction, the challenges in the wildlife impact on agriculture, advanced detection technologies, YOLO V8 detection architecture, data acquisition, methods, results, and comparisons. So our main focus of the survey is that the birds will eat the crops like corn, wheat, rice, sunflowers, seeds, uh, safflowers, and the consumption of consumption of grains, fruits depends the forwards, the lower the quality of the produce, which affects the food security also. An automated system need to be prevent the crop agriculture fields and IoT to solve issues. So here, when the farm the birds will become the plants and they're eating on the grains. Birds cause the economic changes. Okay. And pest management, traditional chemical industries create uh, environmental concerns. So we can use advanced technologies for detecting the birds. So here, integration of deep learning models with IoT users will be the real-time monitoring and alerts, behavior pattern, automated response, and data collecting from the future prevention. So hardware we can be used like NVIDIA Jetson Nano and Raspberry Pi 3B Plus. So for integrating and catch up the image and can be sent to the farmers. So here the OLO V8 detection architecture. So first we will be taking the images from the plants. So when the birds are coming, the images are being captured and the data is being pre-processed along with the OLO V8 algorithm. So if the birds or animals are being detected in the camera, so we can send the ultrasonic sound to the birds. We can give the ultrasonic sounds. So the birds or animals which are coming near to the plants, or when they are more sitting near more than a second, a few seconds, so we can send the ultrasonic sounds. So when they are heading, they'll be run out of the place. So for the data acquisition methods, so what are the types we can use means we can use the drone, provide high angle field monitoring with the NIVID analysis to identify the vegetation's healthy and potential animal activity zone. Animals, where are they? So that that zone can be monitored. Stationary cameras, we can also fix the cameras and catch up the images in the field at the noon time or the dusk side. Also, it can be need to be identify the conditions. IoT sensor like PIR sensor, Wi-Fi models create energy to detect the systems. So we can use the IoT sensor for detecting. So here, normalization difference vegetation index, and it can be calculated by near infrared reflection from the vegetations versus the red strip of red reflections. So with this, we can able to identify calculate the NDVI. So LOV8, you only look once version 8. So it is direction to detect the real-time detection, classifications, segmentation, and post estimation. So using this model, we can able to detect the real-time images and it can be classified and segmented. Okay, how we are using is have anchor-free detection, a type of object detection model that does really predefined anchor boxes. So here we'll be having a bounding of boxes of various size and aspect ratio for detecting the object. Instead of it predicts the pixels and key points and the centers, it can also predict by the backbone, neck, and the head, where which position it is. According to the position, it will be detecting. And the key data sets of the wildlife, the data sets what we are using is Misurio camera traps, which handles of 25,000 type of photos of 20 distinct species, which has the resolution of 1920 into 1080 to the quantity, the pixel size varies from this to 2048 to 15,536. And American wildlife dataset, which consists of at least there is 376 images per animal classes, and IP102 dataset, which consists of 75,000 images from one or two insert pest categories of 19,000 images bounding cost of object detection. Crop pest database, which consists of 24,881 images across with the across of 22 groups covering these types of the crops. So how we are going to implement with the hard disk means with the computational device, we can keep the camera in a place, and if any birds are coming, so in our area, like we'll be growing the rice paddies, we'll be growing more. So when we are when they are cropping the yields, the many birds will be coming at the time, and they'll be eat the all the crops, and all the sudden they will be go out. So for that monitoring and making the farmer to be peaceful, so we are introducing, we are implementing this one. So we have to keep the camera and at least a four corners, and it must be catch up. The image will be catch up and sent to the system. So from the system, we can able to predict using the algorithms whether the birds or animals are crossing. So it will be we are detecting that. After once either the birds or any animals are crossing or detected means we are making the ultrasonic sounds. For this, we are using the Jetson Nano. So 20 watts the socket, and Raspberry Pi can be 3B, and ESP2866 for cloud connecting and sending the alert to the farmers through the mobile applications. PA sensor, passive infrared ray sensor for the motion detection. So any motion has been done means we can able to predict from that. So sound or the image sensor, that is a motion sensor, has been used. So when you're using for the real world applications, the bird activity monitoring, so detects the folks of the if the birds are coming around, so we have to trigger it. So detect the so we are doing that precision of the farmer integrates with the irrigation and fertility system to optimize resource used based on the vegetation's health and wildlife activities. Yearly warning system send real-time alerts to the farmers. Smartphones when the wildlife is direct damage occurs. Before the damage occurs, we are sending the alert message to the farmer, so he will be alerted, and the sound will also be come in the farm field. So these are the sample results which has been taken from the previous literature survey papers. So what is the conclusion is with the combination of innovative equipment such as deep learning, hybrid neural networks, and sensor-based system, grants like order for enhancing the crop field safeguard against the wild animals interruption. By retaining the model like YYLO V8 and ResNet, and delivering real-time image processing and accent examination, the real-world agriculture situation to be safeguard, sustainable and secure rural environment is being formed. Thank
Okay, so with that, we have completed all our presentations for this session, and I'd like to conclude the session now. And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you all for the support during this 9th version of the conference and all the previous 8 versions also. We'll be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to the Springer. The publication will be live within 7 to 8 months, so kindly cooperate with the team of WS4 2025. I'd also like to thank our session chairs for sharing this session. And here is a small token of appreciation on behalf of the team of WS4 to the chairs, Dr. Dalia and Professor Deepika Virat. Thank you so much for your presentation, ma'am. Would you like to give a closing remarks to all the participants?
Thank you so much, ma'am.
Okay.
Thank you.
Thank you, ma'am. So now I'll just request you all to please switch on your cameras for a quick snapshot. Thank you so much, everyone. Thank you. See you again.
Thank you.
Thank you, ma'am.